Algebra lesson 3.3. These notes are about multiplying and dividing. I just now noticed this typo. There's definitely supposed to be an I in there. Multiplying and dividing inequalities. So remember, an inequality is not equal to. So it's going to be less than or equal to, or less than, greater than or equal to. So we've already done adding and subtracting. Now let's look at how to divide. I still want you to start by drawing a line down the middle of the symbol that's your inequality, and still looking at your variable to try to see how to get it by itself. Right now x is being multiplied by 3, so you're going to do the opposite, and you are going to divide both sides by 3. Cancel, cancel, bring down your symbol. 9 divided by 3 is 3. And there we go. And now it says to go ahead and graph the solution as well. So let's review how to graph. We're going to put 3 on our number line with a bullseye right there. Go ahead and show that you know that to the right the numbers get bigger, and to the left the numbers get smaller. And then let's go ahead and review how to graph it. What we're saying here is we want our line to represent x. And right now x is a number we don't know. But what we do know is that it is less than or equal to 3. So somewhere on our number line we need to represent less than. And I hope you realize that less than, the numbers are smaller to the left. So we're going to go ahead and shade less than is to the left. And now this idea of or equal to, that means it could be 3 itself. We don't know what x is, but it could be exactly equal to 3. So we want to shade in the bullseye as well, because it could be exactly equal to 3. All right, I'm going to go a little faster from here on out because that was just kind of a review. Number 2, m is being multiplied by 2, so we're going to divide both sides by 2. Cancel, cancel. M is less than -6 divided by 2. If you're not sure, please use your calculator because you have got to get these negatives, positives figured out. -6 divided by 2 is -3. So always just go ahead and use your calculator if you're not sure. Plot your -3. Numbers to the left get smaller. Numbers to the right get bigger. And then if m is representing numbers that are less than -3, we want to go to the left again. This time it is not or equal to, so we're not going to fill in the bubble. We're just going to leave the bubble open. Number 3. Variable's on the wrong side, but it doesn't matter for now. T is still being multiplied by 6, so we are going to divide by 6 on both sides. T is actually greater, because I'm reading it backwards from right to left. T is greater than -18 divided by 6, which is -3. Okay, so this actually looks a lot like this. The variable and a less than sign. Here's a variable, and if you read it this direction, that's also a less than sign. However, what I want you guys to remember is that, let me get these written down here first. Smaller, 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 bigger, bigger, bigger. Okay, what I want you to remember is if the variable comes last, you have to read it from that side. T are the numbers represented that are greater than -3. So actually we're going to shade greater because T is representing these numbers that are greater than -3. All right, if it helps you to rewrite it the other direction with the variable coming first, just rewrite it. Just be sure you know that it's greater pointing at the T. So T is greater. Okay, if that maybe helps you, that's a good idea. All right, number 4, draw your line. P is being multiplied by 8, so we're going to divide by 8 on both sides. We've got the same situation we had before. The variable's on the wrong side. 40 divided by 8 is 5. So when we go to graph this, we're going to put 5. Let's go 6, 7, 8 this way. Let's go 4, 3, 2 this way. And P is everything greater than or equal to 5. Greater. Remember, read it backwards since the variable started from the wrong side. So greater than or equal to 5. And equal means shade in the bubble. All right, number 5 is different. This time b is not being multiplied by 3, b is being divided by 3. A fraction is a division problem, so you read it from top to bottom. B is divided by 3. So to cancel the divided by 3, we are going to multiply by 3 on both sides. That's supposed to be a little dot. Doesn't really look like a dot. All right, there we go. So divided by 3 and multiplied by 3 cancel. It leaves b by itself. And that symbol, which is greater than or equal, and -1 times 3, if you're not sure, always check with your calculator. It is -3. All right, so we're going to drop a -3. Numbers to the right get bigger. Numbers to the left get smaller. And we want to represent that b is greater than or equal. So greater than is going to go to the right. These are the numbers that become greater. And or equal to means it could be -3 itself. So we want to shade that one in too. All right, number 6 is a decimal. Don't let it scare you. We're still going to solve it the exact same way. Right now, x is being divided by 3. So you're going to multiply by 3 on both sides. Okay, bring down your x, bring down your less than or equal to symbol this time. And 8.7 times 3, I have no idea off the top of my head what that is. So I'm going to use my calculator. 8.7 times 3 is 26.1. So that one's going to be a little harder to graph, but we can do it. So I'm going to put 26 on my number line. And then this would obviously be 27, 28, 29. I had to write really tiny. 25, 24, 23. And I want it to be at 26.1. So it's going to be just barely past the 26. It's kind of a tiny bubble. It's literally right next to the 26 because it's 26.1. I don't know what x is, but I know it's less than or equal to this. So I want to shade less than. And I want to shade or equal to. So I want to actually bubble in my 26.1 as well. All right. You might also put 26.1 here, just so that, because I actually covered up my 26. And this is another reason you show your work here. So I can see that you actually got 26.1, even though it looks like my bubble's on the 26. Okay, here's something new. I hope you did not just skip through this section thinking that it's the same as the top section. This bottom section is new and different, and there's something new to be added to it that you have to watch. Let's start like normal. All right, here's the catch. If you divide by a negative, okay, or down here, if you multiply by a negative. So, you know what? I just want us to go find some space up to the top to write this down. I think if you write it down, it will help you. When multiplying or dividing both sides by a negative, okay, you ready for what you're going to have to do? When multiplying or dividing both sides by a negative, flip the symbol. Okay, so I know it's like, wait a minute, you're throwing me for a loop. I am. This is the rule. This is the rule that I hope you don't forget. That's why I wanted you to take time to write it out right now. You have to flip the symbol anytime you multiply or divide both sides by a negative. Okay, so let's go down to our new section and see what's happening here. I'm about ready to divide both sides by a -5. Okay, it should pop out in your brain that the minute you put a negative there, you should go ahead before you forget and grab that symbol and loop-de-loop, switch-it-a-roo, switch it around the other way. Loop-de-loop, switcheroo, that's the mathematical term. No, I'm just kidding. But that's what I say because I want to make it big. I want to show you guys that you have to flip it. It was less than or equal, now it's greater than or equal. The equal part stays the same. If it was here, it's going to be here, but the symbol flips to the other direction. All right, bring down J. Go ahead and do the math on the right. 10 divided by -5. If you're not sure, check on your calculator. 10 divided by -5 is -2. Okay, if you didn't flip the symbol, then when you go to graph it right now, you are going to shade the wrong direction. You will miss this problem. So let's go ahead and do bigger numbers to the right. Littler numbers get smaller to the left. Now what we have is J is greater than or equal, so it's going to be to the right. If you did not flip the symbol, you will get this answer wrong. It has to be flipped because we divided by a negative. If you divide or multiply both sides by a negative, that's when you switch that symbol. All right, so now let's just practice it a few more times to lock it in your brain. T is being multiplied by -4, so we are going to divide by a negative on both sides. That is your chance to grab that symbol and loop-de-loop switcheroo. I'll stop saying that eventually. Flip the symbol. 4 divided by -4, check on your calculator, is -1. So when we go to graph it, 0, 1, 2, -2, -3, -4. When you go to graph it, T is now less than or equal to -1, so less than. I do not want you guys to miss this because you forget about this rule. Please, please, please lock this rule in your brain. When you're dividing both sides by a negative or multiplying both sides by a negative, flip that symbol. Number 9. Y is being multiplied by -7, so we're going to divide by a negative. That's your chance to grab it and flip it. Okay? Cancel, cancel. -14 divided by -7 and negative divided by negative is +2. Okay, when you go to drop your 2 here, we've got a few things to look at on this one. And that is because it's on the wrong side, first of all. The variable comes last, so we need to read it backwards. And I hope you flip the symbol. So y is actually greater now than 2. So we want to shade greater than 2. If I'm going too fast, pause this video or replay it, whatever you need to do to lock this in your brain. All right, number 10. -6 is being multiplied by a, so we are going to divide by that -6 on both sides. When you're dividing by negative on both sides, grab that symbol, flip it around. All right. A is on the wrong side. We'll talk about that in a second. -24 divided by -6 is +4. All right, so let's drop 4 here on your number line. Read it from the variable backwards, or from the variable whichever direction it's going. So this is saying A is less than, since we had to flip it, A is less than 4. So we want to go less than 4. It's not or equal to, so we're going to leave the bubble open. All right, number 11 is different than ones we've done so far. K is being this time divided by a negative, so we are going to multiply by a negative. So our same rule applies that you wrote up here at the top to hopefully lock this in your memory. When dividing or multiplying, you flip that symbol by a negative. So we are multiplying both sides by a negative. So we want to take that symbol and loop-de-loop, switch-it-a-roo the other direction, because we are multiplying now, both sides by -2. All right, so K is now going to be less than 2 times -2, which is -4. So we're going to drop a -4 on our number line. -3, -2, -1, -5, -6, -7. K is less than -4, so we want to shade less than, which is to the left. All right, last one of these. H is being divided by a negative. So we are going to multiply by -1. And when you multiply by a negative on both sides, you got to flip that symbol the other way. All right, that leaves h is now greater than 7 times -1, which is -7. So let's go graph that. Put -7 on your number line. They get bigger to the right. They get smaller to the left. And what we want to represent is h being the numbers that are greater than -7. So greater goes to the right. All right, last problem on here is a word problem. It says you have $25 to buy 6 fishing lures. Write and solve an inequality that represents the prices that you can pay. We don't know how much the fishing lures cost. We just know all we've got in our pocket is $25, and we would really like to buy 6 of them. So let's think through how to write this inequality. We have 6 fishing lures that we would like to buy. It's going to be multiplied by x because that's how much we're going to pay per 6 lures. So 6x, because 6 times the cost of each lure, which we don't know. And we know we have $25 in our pocket. So let's figure out what symbol it is. It's going to be 6 times an amount is less than or is greater than $25. Could we go over $25? Is it greater? No, all we have is 25. So our amount has to be less than $25. And can it be exactly 25 itself? Since we have 25 exactly dollars in our pocket, it could be equal to. So 6 times the number of times the amount that the lure cost, we want 6 of them, has to be less than or equal to $25. And then it says write it and solve it. So let's go ahead and solve it. We need to divide by 6 on both sides. Since we are not dividing by a negative, we do not need to flip the symbol. Only when you're dividing or multiplying by a negative. So just bring down x, bring the symbol down the exact same way it was because we're not worrying about dividing by negatives. 25 divided by 6, I have no idea what that is. So 25 divided by 6 in my calculator, oops, didn't mean to do that, is 4.16. I'm actually going to bump that up to a 17 because we're talking about money. So the 6 is going to round this up to a 7. So 4.17. And that is cents. So dollars and cents.